Okay, so we're going to do some questions. These are past paper questions from the higher combined paper. Okay, let's have a look. The football has mass of 400 grams. What is the potential energy of the football when it is 0.8 meters above the ground? Use the constant gravitational field strength G equals 10 newtons per kilogram. There are 4 options there. Have a go, see what you get, and then I'll go through the answer. Okay, so we're going to cleanse this. We're going to write out our quantities. So Q for quantities, we've got a mass of 400 grams. I've got, it's asking me what is the potential energy of the football. So energy equals, don't know. When the football is 0.8 meters ground, well, a distance above the ground is going to be height, 0.8 meters. And it's asking us to use gravitational field strength G equals 10 newtons per kilogram. All right, my units, I need to look at my units. I've got mass in grams. In this variable, I've got kilograms mentioned. Well, we can't have an inconsistent unit from one to the other. So what we need to do, we need to convert our mass to kilograms. Okay, and I've got 1,000 grams in 1 kilogram. So if it takes 1,000 grams to make 1 kilogram, 400 grams is going to be 0.4 kilograms. Okay, let's think about my equation. I know that gravitational potential energy is mass times gravitational field strength times height. Okay, hopefully that looks familiar. I can substitute the numbers that I know into that equation. I don't know what E is, so it stays as E, not a question mark. My mass is my converted mass, 0.4, multiplied by the 10 newtons per kilogram we were given in the question, multiplied by the height, 0.8 meters, and that gives me energy equals 3.2 joules. So that is answer B. Okay, question 2. The national grid transfers energy efficiently using high voltages. Why are high voltages more efficient? And there are 4 options there. We're either increasing the voltage, we're either increasing the current or decreasing the current, or we're heating the wire more or less. Different variations, so you're going to have to read through those carefully. Which do you pick? Okay, national grid, that's how we transfer energy from our power station to our home. We want to do it efficiently, which means we don't want to waste any energy in the process. Okay, so we are thinking about efficiency. We're trying to transfer energy from a power station to our home. Heating the wires, that's the wires in the from pylon to pylon in the national grid. We don't want those wires getting hot, because those wires getting hot means that we're going to be dissipating energy to the surroundings. That's going to be wasted. Okay, so we want to heat the wires less. So whichever answer we have, we want to be heating the wires less. So it's straight away A or D. Okay, why do wires get hot? Okay, and it is to do with the current. Okay, current is the flow of electrons in a conductor. Okay, if the current is high, those electrons, as they flow through the conductor, are going to have collisions. Okay, so high current means there are going to be lots of collisions within the conductor, and many collisions means there's going to be heat, which we do not want, because heating the wires up means that we're wasting energy. We're going to be losing energy, which is a bad thing. So we're going to use low current. Okay, so we've got few collisions within the conductor, and that means we're going to have less heat in the wires. Okay, so we had A or D before. We want to heat the wires less by decreasing the current, so D is going to be my answer. Okay, question 3. Which factors affect braking distance but not thinking distance? Okay, A, drinking alcohol with a car full of people. B, speed and drinking alcohol. C, speed and wet road conditions. D, wet road conditions and a car full of people. What do you think? Okay, so braking distance is to do with what might make the car take longer to brake. Thinking distance is to do with people. Okay, people think. Thinking takes time. That relates to your reaction time before you even press the brake pedal. Okay, so let's see what we've got here. We've got A, drinking alcohol and a car full of people. Well, drinking alcohol, that's going to make you're going to take longer to think. A car full of people, that's a distraction as well, so that might make you take a long time to think. So we're looking for answers which do not include thinking distance. So it's not A. B, speed. Well, that does affect braking distance, but drinking alcohol is in there. That's going to affect your thinking distance. We're not thinking about our thinking distance, so it's not B. C, the speed of the car and wet road conditions. That's not going to affect how well you think. Okay, so I think it might be C. Let's just check D just in case. Wet road conditions and a car full of people. Well, wet road conditions, braking distance, okay, but a car full of people, that is going to affect your thinking distance. So it's not D. So C is my answer. Okay, question 4. A parallel beam of white light is reflected from a flat mirror. Okay, there we go. A beam of white light reflecting from a flat mirror. What is it going to look like? We've got 4 diagrams here. Which is the correct one, do you think? Okay, the key here is the word reflection. Okay, we know that when we're talking about reflection, okay, we are talking about, I should be using a ruler here, when an instant ray of light comes in to a flat surface, okay, it is going to be a reflected ray of light is going to be reflected with the same angle. So our instant angle is going to be the same as my reflected angle. Okay, so there is no change in angle. Okay, and we can use that idea to pick D as our answer. Okay, if different colours were reflected at different angles, our mirrors at home wouldn't work. You'd end up looking red and blue in the morning. Okay, so D is the answer. Which row gives the features of the domestic electricity supply in the UK? Okay, well, we've got direct current, yes or no. We've got frequency 50 or 230. We've got voltage 230 or 50. What variation do you think is the correct answer? Okay, well, you need to know that the domestic supply in the UK, okay, it's alternating current, AC. It alternates like a wave, or as a wave, a continuous wave of plus to minus. It's called alternating current, so it's not direct current. So our answer is going to be A or B. Okay, you just kind of need to know this really. The frequency is 50 hertz. That's how many waves per second, how many cycles per second, and the voltage is 230 volts. So that gives me an answer of A.